All right, so today we're going to add and subtract functions in function notation. So just to kind of show you what function notation is going to look like if you want to do addition, is it's going to be either in this form f plus g of x or f of x plus g of x. Either way you see it written, it's really just asking you to take the f function and add it to the g function, just like it's kind of written out right here. And then subtraction is the same thing. You have your f function minus your g function, and then it's just in a different notation right here where it's your f function minus your g function. So today we're adding and subtracting the functions together, and we'll review a little bit of what we did yesterday. So if we're looking at this first set of examples right here, it says if f of x is x squared minus 2x plus 3, and g of x is 2x squared minus 5x minus 8, find f of x plus g of x. Go ahead. So what we're going to do is we're going to take this whole function that's called f of x, and we're going to add it to this whole function that's called g of x. Okay? So we're actually going to take that x squared minus 2x plus 3, and we're going to add to that the 2x squared minus 5x minus 8. And we're just going to combine those together. So how can I combine those together? Yeah, do like terms, exactly. We always start from the highest power to the lowest power. So our highest power here are our x squareds. I have 1x squared here and 2x squareds here for a total of 3x squareds. Then I would go to my x's. I have a negative 2x here and a negative 5x here. So how many do I have? Yep, thank you, negative 7. And then on the numbers, plus 3 and minus 8. It would be, thank you, minus 5. Okay. So when we're combining these functions together, we're really just combining like terms. We've done that before, right? Nothing new. Just again, a different notation. All right, this time it says to do the g function plus the f function. Do you think that's going to matter? Like before I did the f plus the g, is it going to matter the order that I do the addition in? I see a couple people shaking their heads no. How come no? Because addition, it has a certain rule that it follows. Does anybody remember the rule? It starts with the letter C. Nope, it's commutative. Okay? But let's just show it real fast. If I write this in the other order and I combine it together, I still am going to get the same answer because I still am dealing with the same numbers together. I still get 3x squared. I still get minus 7x, and I still get minus 5. And so the question down here says, does it matter what order you add functions in? The answer is no. And the reason, again, is because we can add in any order. That's what the commutative property of addition tells us. Okay? But on this next set of problems, we're going to subtract. Does it matter what order you subtract functions in? Yes. Yeah, it does. You're right. So f of x minus g of x is not going to be the same answer of if you do it in the opposite order. So let's take f of x and subtract g of x from it. Now when I write this out on my subtraction part, I want to make sure that I know I'm subtracting this entire function. So I like to write it in a set of parentheses to remind myself I have to subtract the whole function. Because then that helps me remember that the negative or the subtraction sign has to go through to every term of this polynomial. Okay? Because I have to subtract this part, and I have to subtract that part, and I have to subtract the third part. Everything has to be subtracted. So really what I'm going to do is just run that negative through the parentheses really fast. Okay? So I'm going to rewrite my front part. I still have x squared minus 2x plus 3. Then I'm going to write this as a minus 2x squared. And then the negative and the negative right here make this a positive 5x. And what sign's the 8 going to have on it? Because that negative has to go all the way over to the 8. I would have a negative 8, which is going to make it positive, so a plus 8. So really, again, what I did was I distributed that subtraction through to every part of the polynomial. Then I just have to combine like terms. Okay, we start with the highest power, so our x squareds. We have 1x squared here minus 2x squareds here, which is a total of a negative 1x squared. Then I'm going to do my x's. I have a negative 2 here and a positive 5 here. How many does that get me? 3. Yeah. And then do your numbers. You have a plus 3 and a plus 8 for a positive 11. Okay. So if I take the f function and I subtract the g function, this is my answer. Now we're going to do it in the opposite order to show that you don't get the same answer. So this time I'm going to take my g function, which is the 2x squared minus 5x minus 8, and I'm going to subtract the whole f function, which this time is x squared minus 2x plus 3. So what do I have to do with the subtraction to subtract my whole function?
Flip the signs.
Yeah, really I love that you said that, because really like in math words I have to say we distribute that through to every part. But I love that you just said just flip the signs. That's really what we do when we multiply through by a negative 1 or we take a negative through. So this becomes a negative x squared, this becomes a positive 2x, and this becomes a negative 3. That we're still combining with this first stuff that we had. So again, to just kind of review what we do with subtraction is we just change the signs on everything in the second polynomial, the one that's being subtracted from the first one. Now just combine terms together. We have a positive 2x squared here and a negative 1x squared here, which gives me a 1x squared. A minus 5x here and a plus 2x here, which is a negative 3x. And then a negative 8 and a negative 3, which is a negative 11. So the question is, does it matter which order you subtract in? Well, I did not get the same answers, even though they look very similar, right? It's not the same answer because they don't hold the same values. So yes, it does matter which order you subtract in. So be careful that you do it in the correct order. All right, so on this next section right here, I've given you 4 different functions. I have f of x, g of x, h of x, and k of x. And I ask you to do some stuff with them. This first one says to add 2 functions together. Which 2 am I going to add? The f and the h. Now, do you guys remember the other day when I made a typo and I said it was a plus sign because equal and plus are on the same key of the keyboard and I messed up? Well, I did it again right there, you guys. That equal sign between the x and the 4 should have been a plus sign. So when I add the function of f together with the function of h, I'm going to have x plus 4 from that function. And I'm going to add it together with my h function, which is this one over here. So it will be plus x cubed plus 2x squared plus 4x minus 8. And I really am just going to combine like terms from there. I always start with my highest power and go to my lowest power. So I'm starting with x cubed. There's nothing to combine with it, so I just rewrite it. Then I go to my x squared, and there's nothing to combine with it, so I just rewrite it. Then I get to my x's. I have 1x here and 4x here for a total of 5 x's. And then what about my numbers on the end? I have 4 here minus 8. That would be a negative 4. Anybody want to ask questions on how I did that? Are we good? All right, what am I asking you to do this then? This time then I'm asking you to take the g function and subtract off of it the k function. So I'm going to come up here and I'm going to grab my g function, which is a negative 4x squared plus 2x minus 3. And I'm going to subtract off the g function, remembering that I'm subtracting everything in the g function. Which again, I like to put my parentheses there to show that I have to subtract it all. And then I'm just going to have to take that subtraction sign to every part of that. So coming here, here,
Wait,
and there.
so the g function and the k function?
Oh, I wrote G and I was supposed to do K, huh?
Yeah.
You guys are right. Thank you for noticing that. I went up and I grabbed the G function, and Tara's right. I should have grabbed the K function, which is a lot nicer math, isn't it? So instead of this, which was the G function, I should have subtracted off the K function, which is 5. So I'm just going to rewrite that real fast. I'd have negative 4x squared plus 2x minus 3. And then I'd minus off the K function, which is just a negative 5. Thanks for catching that mistake. So combining like terms now. We're going to start with the 4x squared negative because we don't have anything else to combine with it. We don't have anything to combine with the 2x, but what do these numbers right here combine together to be? Negative 8. Okay. Questions on how I did that? Again, I'm sorry I wrote down the wrong function. All right, this time though I get to use g, right? I get to use my h function and my g function. And what am I doing with them? I'm adding them together. I'm going to start with my h. So x cubed plus 2x squared plus 4x minus 8. And I'm going to add that to the g function. So I'm going to show you another method that I've shown you earlier in the year where we can stack like things and combine them together. So when I write this down, I'm going to stack the terms that are like together. And then I'm just going to add straight down. Do you guys remember me showing you that before earlier in the year? Yeah. I like this. It makes it cleaner. So if you have terms like that, it would be nice to stack them. You can clearly see you only have the x cubed. And then when you do your x squareds, you have 2 minus 4, which is a negative 2 of them. You have 4 plus 2, which is 6. And then a negative 8 minus 3, which is a negative 11. Questions on how we did that? Okay, a couple more on the back. Again, I recopied the functions over here for you, so that equal sign is supposed to be a plus sign over there. Sorry about that. And then this time on number 4, I asked you to do k of x minus f of x. So if you go grab your k of x, it's 5. And you're going to subtract off your f of x, which is x plus 4. Again, I like to put the parentheses because it helps me remember that I have to take that negative through to both parts. So when I rewrite that, that's really 5 minus x minus 4.
You're done with this one. Didn't you go back to the last one before this?
Yes. So negative x, and then 5 minus 4 would be 1 for my solution. All right. This last one that we just did,
Yeah.
you just need a little bit more time on it.
Here, I'll tell Drew.
All right, number 5 then. The only thing that's different with number 5 is I ask you to do more than just 2 things to it, right? There's 3 functions here. So when you do this, you're going to combine the first 2 together and then find that answer and subtract off k. I mean, you could write it all out as one big long function if you wanted to, but we're going to grab f of x, which is x plus 4. Then we're going to add to that g of x, so we're going to add negative 4x squared plus 2x minus 3. And then even if I wanted to, right here, I could write out minus k of x, and our k of x is 5, so I could go minus 5 and just combine like terms. You totally could have just done those two together first, though, the addition, and found that answer and then subtracted off the k. It would have worked that same way. But where that k of x is just 5, it's probably just as easy to do it up front. So you start with your highest power, which is those negative 4x squareds. You go to your x's, which would be 3x. And then you combine your like terms with your numbers. So 4 minus 3 would be 1. And 1 minus 5 is negative 4. Okay, are there questions on that? So really, again, when you're doing addition and subtraction together, you just go left to right and write it out the way that you would do your addition and subtraction. Okay, one last problem here. Is there a difference between f plus g of 2 and f of 2 plus g of 2? What do you think? Is there a difference if you add them together first and then put 2 through them, or if you put 2 through them separately and then add the answers together? Anybody have a thought? Should we just do the math and see? Okay. So this one says add the two functions together first, right? So we're going to go up and we're going to grab our f of x up here, which is x plus 4, and grab our g of x, which is the negative 4x squared plus 2x minus 3. And we're going to add them together first. So I just went up and I grabbed my functions, and I'm going to combine like terms here. So we'd have a negative 4x squared plus 3x plus 1. And now that I've done that, I'm going to put the 2 through it. So I would have a negative 4 times 2 squared plus 3 times 2 plus 1. You guys give me that answer and shout it out when you have it.
Negative 8x squared plus 6x plus 2.
Okay, so did you substitute that 2 in place of the x?
No.
So put the 2 in place of all of the x's.
Okay.
But
-9, isn't it?
I got negative 9 when I did it. But you guys check to see if you got negative 9 to just be sure. But Will's right, negative 9. Again, that's because 2 squared is 4. 4 times negative 4 is negative 16. Negative 16 plus 6 and then plus 1 gives you a negative 9. Okay, so that was this way, right? We added them together first and then we put the 2 through it. This time I want to find my f of x function, and I want to put the 2 through it first, and then I want to take my g of x function and put the 2 through it and see when I add them together if it changes my answer, okay? So if I put 2 in here, I'd have 2 plus 4, which is 6. If I put 2 in here, I'd have negative 4 times 2 squared plus 2 times 2 minus 3. So 4 times negative 4 is a negative 16 plus 4 minus 3. That adds together to be negative 15, right? So when I add 6 and negative 15 together, what did I get?
-9.
So did it matter which way I did that? Nope, because guess what I got both times? I got negative 9 both times, okay? So again, the reason that happens is because addition has a special property that's called the commutative property. You can add in any order and still get the same answer. So because we were still adding these together and adding these together, it didn't matter which order I did it in, I will still get the same answer back out, okay? Questions on what we've done?